Good morning. Today we will be working on square root functions. This is part 1 of 2. Today we will work on parent function attributes, transformations, and domain and range of the parent function and of the transformations. Again, everything revolving around square roots. So this is a picture of the square root parent function. What do we notice about it? We notice that the graph starts at 0, 0. Now if you think about this, we are taking the square root. What is the square root of 0? The answer is 0. That is where 0, 0 comes from. And then our next point, what's the square root of 1? The answer is 1. Now notice that nothing else is a whole number until we do the square root of 4. The square root of 4 is 2. So notice that in order for this to be a function, this is only the positive square root. Because we know that when we take the square root of a number, it has a positive and negative solution. But for the sake of being a function, we only do the positive solution. Let's discuss domain and range, and we're going to work on writing the domain and range in 3 different notations. We have interval notation, inequality, and set builder. So what is the domain? Domain is going to be my x value. So my lowest x value is going to be 0. And my x value is going to go on forever. So what is my highest x value? Well, if it goes on forever, it goes to infinity. Now, parentheses or brackets. Well, we can never touch infinity, so that's always a parentheses. Now, let's talk about the 0. The square root of 0 is 0. It does touch it, and so that's a bracket. Now, how do we write that in inequality? Well, x is from 0 to infinity, so we can just say that x is greater than or equal to 0. X can be any number as long as it's 0 or greater. Now, don't forget that the bracket represents that it can be equal to it. Set builder, we do our curly bracket, x such that straight line means such that x has to be greater than or equal to 0. So inequality and set builder are very, very similar. Now let's talk about range. Range, my lowest y value starts at 0. How high up can this graph go? Well, we see that it goes here, here, here. It's actually never going to stop. So my y value is also from 0 to infinity. And again, the 0 is a bracket, the infinity is parentheses. In equality, we say that y is greater than or equal to 0. And the set builder is going to be y such that y is greater than or equal to 0. So I'm going to ask that you memorize the parent function, at least what it looks like. If you can graph those 3 points, the square root of 0, the square root of 1, and the square root of 4, and that's enough to make your parent function graph. Okay. Now we're going to get into transformations. So the parent function was just the square root of x. There was no visible a, b, h, or k. So we're going to talk first about a. What does a do? Well, first of all, a has to be in front of your square root. A cannot be inside. A is in front of your square root, so it's being multiplied by your square root. A causes a vertical stretch or a vertical compression. Now, we look at the absolute value of A. I don't care if it's a negative. If it's a -5, that means it's a vertical stretch. If it's a -1/5, it's a vertical compression. So the negative doesn't control the stretch or compression. So we're just looking at the absolute value. So just the positive value. Greater than 1 stretch, less than 1 compression. Now if it is a negative, it's going to cause a reflection over the x-axis. So what does that mean? Well, we saw that the parent function looked like this. If A is negative, it causes it to flip over this axis. And so if A is negative, it's actually going to be like this and going down forever. So let's do 2 practice questions. Let's just discuss the transformations. So in this one, we are doing 5 square roots of x. The 5 causes a vertical stretch. Okay? It has a vertical stretch of 5. But does that vertical shift change my domain or range? Well, vertical shift means the graph is going to get taller, taller, taller very, very quickly. Okay, it's not drawn to scale. But did my domain change? Did the graph shift left, right at all? No. So my domain is still 0 to infinity. You can choose any way to write it. I am a fan of interval notation, so that is what I will be using. Well, my range. Did my range get affected? Did my y value get affected? The answer is no. So my range is also 0 to infinity. Let's try the second one. Okay, I see a negative and I see a 2/3. The negative causes it to reflect over the x-axis. The 2/3 causes it to compress, okay? And a vertical compression means it's going to get closer to the x-axis, okay? So this graph did not shift up or down. So my corner, my starting point did not shift up or down. But it did reflect over the x-axis, and because it's a vertical compression, it's getting closer to the x-axis than the parent function. So again, it's reflection over x-axis and a vertical compression of 2/3. Let's discuss domain and range. For the domain for my x value, did the graph shift left or right at all? No, it did not. So my domain is still 0 to infinity. Now my range, the graph is going down forever, okay? As you can see, this graph is going to go down, and it's going to keep going down, 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 down. So what's the lowest? We always start with the lowest value. The lowest value the graph is going to go is negative infinity. So how high up can this graph go? So it's going to go down forever. What is the stopping y value? The stopping y value is 0. Again, our lowest y value to our highest y value. Go ahead and try number 3 on your own. Okay, check your work. So the negative caused it to reflect over the x-axis. The 2 was a vertical stretch of 2. A stretch means it's getting further away from the x-axis. So my domain did not change. So what are we noticing? That A does not affect your domain ever. Okay? But A can affect your range if it causes it to flip over the x-axis. Okay? So let's go ahead and try number 4 on your own. Okay? What do we see here? We see a number that's less than 1, between 0 and 1, because remember, we're looking at absolute value. So it's a vertical compression of 1/2. Vertical compression means the graph got closer to the x-axis. Okay? Now, the domain, remember, A does not affect your domain. A is not going to make your graph shift left or right. And my range, because the graph is going up, the range is going to be 0 to infinity. Of course, with brackets on the 0 and parentheses on the infinity. Okay, now we're going to talk about the b value. The b value is going to be inside the radical in front of your x. Okay, if the b value, if the absolute value of b, so we only care about the number, if the absolute value is greater than 1, it's a horizontal compression by 1 over b, which means you have to flip it. That means if you had the square root of 4x, it would be a compression of 1/4. Okay, so you always take the reciprocal, you always flip it. If you had a 1/2 x, that means it would be a horizontal stretch. And yes, I had a typo. I apologize. I fixed it. Horizontal stretch, but we have to take the reciprocal. So this would be a horizontal stretch. Well, what's the reciprocal of 1/2? It would be 2. And if b is a negative, it causes it to reflect over the y-axis. So here was our parent function. If b is negative, it causes it to flip this direction. It's a mirror image over the y-axis. We're just going to do a couple questions with b. Again, we don't see b as much as we see a, so I'm going to do just 2 examples here. The b value is going to be inside the radical in front of x, okay? So this causes a horizontal stretch or horizontal compression. Is it getting closer to the y-axis or further away from the axis? So my transformation is a horizontal compression by the reciprocal of 3. What's the reciprocal of 3? It's 1/3. Okay, so this b value does not change the domain either. The b value is still going to start right here. And this is the square root of 3x. So this is going to make the graph actually get closer to the y-axis. And a horizontal compression makes the graph do what a vertical stretch does. Okay, it makes it look like it's getting a little bit taller. The horizontal compression is pulling it to the y-axis. My domain did not change. My domain is 0 to infinity. My range did not change. My range is also 0 to infinity. Now the next one, I'm going to want you guys to really think about this, okay? So this graph starts, they all start at 0, 0 because it did not shift left or right at all. Now guys, it caused a reflection over the y-axis, okay? And it caused a horizontal stretch of the reciprocal. Okay, so I wrote it down there. Again, a horizontal stretch by 3/2 because you have to take the reciprocal. And it caused it to reflect over the y-axis. So a horizontal stretch is like a vertical compression. The graph gets skinnier and goes the other way. Okay, now my domain is affected. Because it reflected over the y-axis, what is my lowest x value? Well, it's going forever to the left. That's negative infinity. Where does my x-axis change? Where does it end? My domain is going to be negative infinity to 0. My range is still my lowest y value. And how high is the graph going to go? Well, it's going to continually go up forever. So my lowest y value is 0. My highest is infinity. So what we've noticed so far is that A can affect your range, B can affect your domain, okay? And the only time it affects it, the only time is if those values are negative. If those values are positive, they do not affect your domain or range at all. The next value to discuss is your h. Now the equation has a negative h, which means since you see a negative in front of this equation, whatever number you see here, your h is going to be the opposite sign. So if you see a -2, that means h is really a +2, and that means the graph is going to the right too. So h has to be underneath the radical, and h will always be the opposite of what you see. And h, after you change the sign, then you say if it's a positive or negative. After you change the sign, if you see a +2, this is to the right 2. If you see a -2, it's to the left 2. What is it going to change, the domain or the range, if it's shifting the graph left and right? The answer is it's going to affect your domain, because the domain is left and right. It's your x-axis. So let's try 2 examples together. Okay, h has to be underneath your radical, but h, we're always going to change the sign. So my h is really a +4. So this graph is going to the right 4. So we started here originally, but the graph is now shifted to the right. And so this graph is going to go that direction. What's my domain? What's my lowest x value? 4. That number right there, it's not, none of these numbers are part of this graph. The graph starts at 4 because the graph moved to the right 4. How high is it going to go? Infinity. Range, what's my lowest y value? My lowest y value is 0. How high is it going to go? Infinity. So notice that the h value is going to affect your domain. Example number 2. Whatever you see here, you change the sign. So h is really a -1, which means this graph is going to the left 1. So instead of starting at 0, 0, we're going to go to the left 1. And h cannot make it reflect anywhere. H just moves it left and right. So remember, h is going to affect only your domain. So my domain is now -1 to infinity. So h affects your domain. My range, my lowest y value is 0. My highest y value is infinity. Try question number 3 on your own. Now check your work. What was the h value? The answer is a -2, which caused your graph to go to the left 2. And so since the graph moved to the left 2, it affected your domain. My lowest x value is -2. And remember, we use brackets if it is on that value. So it is on -2. And the x value is increasing forever to infinity. The y value. What's the lowest y value? 0. How high up is it going to go? Well, it's going to continually go up forever. So this graph right here that you see is constantly going over and over and up. Okay, try the next one on your own. Okay, now we get to discuss it. So this h value, we changed the sign and put +3, which made your graph shift to the right 3. So remember, we always start at 0, 0, but it went to the right 3. And so my domain now starts at 3, and my domain is going to go to infinity. My range, my lowest y value is 0, and it's going to go up forever to infinity. Remember that 4 square roots, the numbers are going to have brackets. The infinities always have a parentheses. Our last variable that causes transformations is your k value. Now notice where k is located. K cannot be underneath your radical. K is either going to be added or subtracted. This is going to cause the graph to shift up or shift down. If it's positive, the graph shifts up. If it's negative, the graph shifts down. What effect do you think this is going to have on my domain or my range? It's going to affect my range. This is going to make my y value go up or go down. Okay, start higher or lower. So remember, the k value cannot be under your radical, so it'll always be after. And the k value, we don't have to change signs. So k is a +2, so the graph shifts up 2. So remember that the parent function starts at 0, 0. Because the graph went up 2, it starts on 0, 2. And the graph is going to go up and in the same direction. My domain, that didn't change my domain. My lowest x value is still 0. My highest x value is infinity. But it affected my range. My new low y value is 2. But it's going up forever to infinity. My second one, my k value is -3, which means this graph is going down 3. So that is my new starting point, and the graph is still going in the same direction. Did that affect my domain? No. What's my lowest x value? 0. What's my highest x value? Still infinity. But it did affect my range. What is my lowest y value? -3. How high up is this graph going to go? Infinity. Okay. Now try number 3 on your own. Now let's discuss it. That -1 caused the graph to go down 1. My domain did not change. My domain is still 0 to infinity. But my range now, my range did start at -1, and it's going up forever. Okay? Try the next one on your own. Let's discuss it. The k value is +3, so the graph shifted up 3. It did not affect my domain, so my domain is still 0 to infinity. My range, my y value starts at 3, and the range is going up forever, so it's 3 to infinity. Don't forget for square roots, the numbers are always going to have brackets, and the infinities are always going to have parentheses. Now, what if the problem has multiple transformations in one? So, this graph, this number is underneath the radical, so this is your h value. Your h is always the opposite of what you see. So h was really a -1, so the graph went left 1. The 2 at the end is outside, so that is your k value. Your k value is a +2. So the graph went up 2. So remember that we're going to start on 0, 0 for our transformations, but the graph went left 1 and up 2. If A is positive, and it was, this graph is still going to be facing this direction. Now, guys, I don't need exact points for my graph. All I want to know is which direction it's going, because that's going to help me with my domain and range. So my domain is my lowest x value. My lowest x value is -1. So my domain is -1 to infinity. My range, my lowest y value is 2. So my range is 2 to infinity. So notice that the h affected my domain and the k affected my range. So h and k are actually going to be my starting points. If you can think back to quadratics, that h and k were my vertex for my quadratics, it's almost the same thing here. Okay, it is my starting point. On the second problem, what's happening to this graph? Well, I actually have 3 different things happening. The negative causes a reflection over the x-axis. The 2 causes a vertical stretch of 2. And this -2 down here makes the graph go down 2. That is my k value. So what does that mean for my graph? Well, my k made it go down 2. The a does not change my starting point, but a did say it's going to reflect over the x-axis, so it actually is going to flip upside down, okay? And it's going to have a vertical stretch of 2. What I mean by flip upside down is it's now going the opposite direction, and vertical stretch just means it gets taller quicker, okay? So my domain, what is my lowest x value? 0. Highest x value? Infinity. Range, what is my lowest y value? And this is where people struggle. Lowest y value, how low is it going to go? It's going to go -infinity. How high is it going to go? What's the highest point? -2. Don't forget that your domain and range is always the lowest value to the highest value. So I want you to try these 2 on your own. Go ahead and try number 3 first. Okay, my transformation was a vertical compression of 1/2. My h, I always change the sign of whatever is underneath the radical. So my h was really a -2, so the graph went to the left 2. Now remember, your domain is affected by your h and k. So this graph is going from -2 to infinity. My range is going from 0, and it's going to go up forever to infinity. Second one's a little bit trickier because you have a b value, which is in a negative. So go ahead and try your best on this one. Let's see how you do. I told you this would be a little bit trickier, okay? So this -2 caused it to reflect over the y-axis. So remember, the parent function looks like this. Well, the parent function now flipped this way, and it went down 2. So now my domain, how far to the left is the graph going to go? Forever. So negative infinity to 0 is my domain. Notice how my h is 0, so my domain still stops at 0. Okay, and my k is not, negative 2 is my range. My lowest y value is negative 2, and it's going to go up forever, so to infinity. So I am going to just ask you a couple questions about this one, and then all the answers will be displayed. So we'll go ahead and just look at both of these and answer the few questions. So I started the first one. So this graph had an h value of positive 2, so it went to the right 2 and up 3. So that is my starting point. And because there's no, we don't have to worry about a or b, the graph is going to look just like the parent function, just shifted. So remember, your h and k affect your domain. So my domain, what's my lowest x value? The answer is 2. Highest x value, infinity. Now try the range on your own. The range is going to be 3 to infinity. Okay. The next graph, my a value is 3, so it has a vertical stretch of 3. The k is a negative 1, so the graph went down 1. So graph went down 1. Vertical stretch of 3 means it's just going to grow rapidly. Okay. There is no h, so think about my domain. My h is 0 to infinity. My k affects my range, so my range is negative 1 to infinity. Hopefully this video helped with transformations of square root functions. If you like this video, go ahead and give it a thumbs up, subscribe to this channel, and I will be posting more educational videos.